So just before we move on to numerical methods, there's a bit that's missing from your notes. So just copy this one first. A curve is concave when your second derivative is less than or equal to 0. A curve is convex when your second derivative is more than or equal to 0. I'll explain it further by showing you a few diagrams, and then we'll work through these questions on page 259 of your Year 2 book. So if you look at your notes, actually, if you look at your textbook, it's exactly what I just said. It is on page 257 of your Year 2 book. And we're going to look at convexity and concavity of any graph. So let's look at a few diagrams. For example, we can draw a quadratic for 5x minus x squared, and we will know it's a negative graph, so it would have a maximum. But what the second derivative also does is tells you about the concavity and convexity. So if it's like this, basically a cave, you can call it that this is the point where the graph is concave. So this graph, this quadratic graph, is actually concave for all values of x. Yes, because that's why it's got x for all real values. Similarly, an exponential graph, if you look at exponential graph, this is the opposite. It's not concave, it's convex. And when you do differentiate e to the x, you get e to the x. So if you differentiate e to the x again, you will get the exponential graph back. So that's why it will always be convex for all values of x. But if we look at this graph, which is actually a cubic graph, and we know cubic graph sometimes does have a minimum and a maximum point. But when we talk about concave and convex, what we need to look at is the range of values for which we get a concave, this part here, and convex. Okay, so from this point onwards, you can see it forming a concave, and this part here is forming a convex. That's why the curve is concave for all values of x less than or equal to 2, where it's convex for x more than or equal to 2. When I do a few more examples, you will understand it better.